Now let's start reading it. The radii of a pedal sprocket, the wheel sprocket, and the wheel of a bicycle in the figure are 4 inches, 2 inches, and 14 inches respectively. And they do give me a nice picture of this. A cyclist is pedaling at a rate of 1 revolution per second. Let's start working our way around the problem. I know there's questions over here, but I want to talk about, how to do the problem. I'm going to start talking about one thing at a time. I'm going to talk about this pedal sprocket, and that's going to be V1, which is actually the velocity of the chain, by the way. That's a linear velocity. R1, and that's the radius of that pedal sprocket, times omega 1, which is the angular speed of that sprocket. Now, what do I get there? Its radius is 4 inches. I'm looking at the picture. The angular velocity of that is 1 rev per minute, per second, I'm sorry. And I know I can't use that, so I got to go to radian. So it's 2 pi over 1 rev. This looks like a pretty simple computation, and that's going to be 8 pi inches per second. Now, by the way, the chain is rotating. I'm sorry, it has a linear velocity, but it's rotating that sprocket behind us. So what do I want to claim over here? The sprocket here, just the wheel sprocket, there's going to be a velocity of that. And what's going to be? It's going to be the same. The chain is the chain. It's moving those objects, by the way. So this is going to be R2 times omega 2. Now, what's V2? It's the same thing as V1. So it's 8 pi inches per second. What's R2? It's 2 inches. What's omega 2? Well, that's easy to do. Omega 2, divide both sides by 2 inches, and you get 4 pi per second is omega 2. Now I'm going to do the big wheel. What's the big wheel going to be? V3. Well, there's going to be R3 and omega 3. I hope you realize that the sprocket on the wheel and the wheel are rotating at the same. So W3 is the same thing as W2. Let's write this down. So V3 is R3, which is 14 inches. And what's omega 3? It's 4 pi per second. By the way, I noticed they want this in feet per second and in miles per hour. So I got to figure that out first. So the first thing to do is know that there's 12 inches in every 1 foot. So what do you get over there? The inches would cancel off, and you get what? Let me think about that. I got to do the arithmetic over here. And that would be 14. Put this over here. 14 thirds of a pi. Let me see if I did that right, because 4 goes into 12 3 times. You get a pi, and that's feet per second. This one's done. I'm going to do miles per hour now. So V3 is equal to 14 pi over 3 feet per second. I want to get rid of feet and go to miles. There's 5,280 feet in every 1 mile, and there's 3,600 seconds in every 1 hour. Now, Greta, I realize you're probably killing it at this point, but you can do the arithmetic. It might take you some time to get through it, but kind of looking at it, it really doesn't look that bad. But you'll eventually get a number. The number you'll get is 35 pi. And again, I'm not going to bore you with the details of the arithmetic, but what I would be doing is looking for reductions, like 3 goes into 3,600. It's a nice number of times. I divide through by 10, then I divide through by 2, blah, 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 and I get a really nice looking number out of it. And what's that going to be? Let's just take a look at the units. Feet cancels off, seconds cancels off, and you're left off with miles per hour. All right? So is that the answer over there? Of course, it's the answer we get over there. Now, I'll say that I'm thinking that part A is a rather straightforward question, although it took some time to get there. All right? So what I want to do is talk about the next thing. It says, use your results from part A to write a function for the distance in miles a cyclist travels in terms of the number n of the revolutions of this pedal sprocket. And that seems like it's a rather difficult question, by the way. But I do know, the velocity, all right? And I want to put out what I mean by that. Distance, right? That's what they're asking about. So distance is equal to the rate times the time, all right? Now, again, it might say, what is that? I write that down for you, but I got to figure out a formula for this now, all right? And the formula is going to be use your results from part A. I got A. And it says to write a function for distance, d, in miles of a cyclist travels revolution of the pedal sprocket. But it's got to be in miles, by the way. So let me think about what I got over here. And someone says, what do you mean, what do you have? I have miles per hour. I know the rate. And the rate's going to be what? Let's think about that. It's going to be 35 pi over 11. And that's miles per hour. All right, I know that much. Now, the t is a little bit more complicated, and I'll tell you why. I'm looking at this thing over here, and I got to figure out what to do about it. And the thing about this one, the sprocket, kind of running out of room over here. Let me just see if I can, what I'm going to do, I'm going to erase what's above it, at least a little bit of it. And, maybe I better not do that. So I'm going to say that I know the sprocket, right? There's 3,600 revolutions per hour. All right? There's 3,500 revolutions per hour. And then the question becomes is, I got to put something down now, right? So looking at this thing over here, I definitely want to get an hour. So I'm going to say 1 hour is the same thing as 3,600 revs. All right, I got that part covered. And then the question becomes is, you got 1 hour with 3,600 revs. I guess I could sort of write that down, right? So, 1 hour, 3,600 revs. All right? So 1 hour, there's 3,600 revs. Still getting this D thing over here. Then the question is, what are you doing now? Well, you have to know the number of revs, and that's going to be, well, they said there's going to be n of them, so n revs. What cancels over here? Well, certainly the hours cancel off, and the revs cancel off. And what are you left off with? 35 pi n miles over 3,600. Now, if you simplify that, you're going to get 7 pi over 7,920 n. And this is going to be miles, by the way. All right, this is miles. All right, they got that. They do say in miles, by the way. Now let's do the next one. It says, distance d in miles traveled t seconds. And I got to write that down now, too. And someone says, well, why are they writing that down? I think it's almost the same problem. Distance equals rate times time. And let's write this over here. So distance, the rate is still going to be 35 pi miles per hour. And then I got to write this thing down about the seconds. And what do you get over there? Well, I got to get rid of that hour in terms of seconds, right? And I'm going to say 1 hour. Put this over here. 3,600 seconds. And by the way, the t is in seconds, by the way. So I know I'm getting something over here, and that's going to be t seconds. Again, they did say that, yeah. So what cancels? Hours cancel, seconds would cancel, and then you got to do the arithmetic over here, and you're going to get the same result. You're going to get 7 pi over 7,920 t. Now, you may wonder why that is. 1 second and 1 revolution are equivalent in this problem because you're doing 1 revolution per second. And we're done. This is still in miles, by the way. And we're done. Was this a tough question? I do believe a tough question. I also believe it would be an unfair exam question. But the bottom line is you have to start to realize that a lot of times exam questions, they're really not trying to tax you too much. You might think they are, but they're not. But really, where you should be being taxed is in the homework. You should be doing things that are really difficult in homework, by the way. Exams should be more or less, do you understand the basic concepts that we're doing? This is a good question, by the way. Do realize that. I'm going to say straightforward, thinking, but they all work out beautifully. Thank you.